Hi, my name is Richard and welcome. Today our discussion on vectors will be finding the vector equations of a plane. So far I have a video where we find the vector, the parametric and the symmetric equation of a line. If you have not watched that video, please check it out on YouTube or you can get that video at the end of this video. Today before the video ends, we'll learn how to find the vector equation of a plane that passes through 3 points. This will be a very interesting engagement, so please, I indulge you to watch the video till the end. So if we have a plane of this nature, okay, let's say we have a plane like this, what we must know is that there is always a normal vector acting on this plane. So let's say a normal vector n acting on this plane. So if the plane passes through 3 points, P, Q, and let's say R, and the point P are x1, y1, and z1, and the point Q is x2, y2, and z2, and that of R is x3, y3, and z3. And let's say our normal vector n is equal to ai plus bj plus ck. Then we can say that the vector equation of this plane will be given as a bracket x minus x1 plus b bracket y minus y1 plus c bracket z minus z1 equal to 0, where a, b, and c are the coefficients of the normal the unit vector of the normal vector. So this unit vector, the coefficient of the I here is A, then that of the J is B, and that of the C is K. So if we know the normal vector and we know a point, we can be able to find the vector equation that passes through 3 points. So the first thing we must learn is that we must learn how to find the normal vector acting on the plane. Then, with our knowledge in finding the normal vector acting on a plane, we can find the vector equation of any plane. So please come with me. So let's say this plane passes through these 3 points, P, Q, and R. And the normal vector n is acting on the plane. And we need to find that normal vector. That normal vector is nothing but the cross product of the directional vectors of the points. What are we saying? We say the normal vector n will be equal to the cross product of the directional vector. So the directional vectors are PQ cross PR. So immediately we find the cross product of PQ and QR. That becomes the normal vector. So let's say we know our PQ to be equal to, let's say, x1i plus y1j plus z1k. And we note our PR, the directional vector PR, to be equal to x2i plus y2j plus z2k. Then the cross product will be equal to the directional vector. So the directional vector, that cross product will be I will just be the determinant of that. So ijk x1, y1, z1, then x2, y2, then z2. When we find the cross product of this directional vector, then that will become the normal vector of the plane. So we'll take some sample questions, then we'll learn how to find the normal vector of a plane that passes through 3 points. So we said before we can find the vector equation of a plane, we need to know the normal vector acting on the plane. So let's learn how to find the normal vector. So find the normal vector of a plane that passes through the points A, 1, 2, 2, B, 2, negative 1, 1, and C, negative 1, 3, 0. So how do we do that? We said that the normal vector N is equal to the cross product of the directional vector that of the 3 points. So we can say the normal vector A is equal to AB cross AC. So we need to find AB, we find AC. Then we find the cross product. So our AB will be equal to OB minus OA from the triangular property of, vectors. So what's our OB? Our OB is this. That's 2, negative 1, 1 minus OA. And what's our OA? Our OA is 1, 2, 2. When we subtract, we get our AB to be 2 minus 1 is 1, negative 1 minus 2, that will be negative 3, and 1 minus 2 will be negative 1. So we need to find AC2. Since we know AB and we are finding the cross product of that, we need to find AC. So our directional vector AC will be equal to OC minus OA. What's our OC? This is our OC, negative 1, 3, 0. So we say negative 1, 3, 0 minus the A, which is 1, 2, 2. So 1, 2, 2. We subtract that, we get our AC to be equal to negative 1 minus 1 will be negative 2. 3 minus 2 is 1, and 0 minus 2 will be negative 2. So this becomes our AC. So we say that the normal vector is AB, the directional vector AB cross the directional vector AC. That's the directional vector of the 3 points. And we find AB to be this, AC to be that. So we can find a normal vector. So our normal vector, this will be equal to the determinant of that. So we say I, J, K, we have 1, negative 3, negative 1, then negative 2, 1, negative 2. So we find the determinant of this 3 by 3 matrix. So how do we do that? This will be I, the determinant of negative 3, 1, negative 1, negative 2, minus J, if you remember very well. So I'm using plus, minus, plus. So we have 1, negative 2, negative 1, negative 2. Then plus K. So we'll not take what is under it. So we have 1, negative 2, negative 3. So how do we do? So when we pick the I, we will not pick what is under the I. So we'll pick what is under the other units. So there's negative 3, 1, negative 1, negative 2. Negative 3, 1, negative 1, negative 2. Then the J, we will not pick what is under the J. So we'll pick 1, negative 2, negative 1, negative 2, 1, negative 2, negative 1, negative 2. Then the K will not pick what is under the K. You have 1, negative 2, and negative 3, 1. So when we solve this, we'll get J bracket. This times this will be 6. Minus this times this will have plus 1. Minus 1 times negative 1 will be plus 1. Minus J, this times this will be negative 2. Then minus this times this, that will be 2. Negative 2 times negative 1 will be 2. Then plus K bracket. This times this is 1. Minus this times this, that will be 6. So minus 6. We'll solve this very well. We have I, 6 plus 1 is 7. then minus j, negative 2 minus 2 is negative 4, plus k, 1 minus 6 is negative 5. So we get 7i plus 4j minus 5. Then this becomes our normal vector. So we said that in order to be able to find the vector equation of a plane, the normal play a very essential role. So let's solve one more question on finding the normal of the plane. So we said find the normal vector of the plane that passes through the points P, negative 2, 4, negative 3, Q, 1, 3, negative 4, and R, negative 6, negative 8, negative 3. So we say that the normal vector N will be equal to the cross product of the directional vector of the 3 points. So we say the cross product of PQ and PR. So we say PQ cross PR. So how do we find PQ? Our PQ will be equal to OQ minus OP. So what's our OQ? Our OQ is 1, 3, negative 4. That's this. Minus OP. OP is negative 2, 4, negative 3. That's this one. I'll subtract our PQ will be equal to 1 minus negative 2, that will be 3. 3 minus 4, that will be negative 1. Then negative 4 minus negative 3 will be negative 1. That will be negative 4 plus 3. So we need to find PR2. The directional vector PR to be equal to OR minus OP. So what's our OR? The OR is this, negative 6, negative 8, negative 3. So negative 6, negative 8, negative 3. Minus OP. The OP is negative 2, 4, negative 3. Negative 2, 4, negative 3. We'll subtract that. Negative 6 minus negative 2, that will be negative 6 plus 2. That will be negative 4. Then negative 8 minus 4 will be minus 12. And negative 3 minus negative 3, that will be negative 3 plus 3. And that's 0. So we say the normal vector N is PQ cross PR. And we find PQ to be this, PR to be that. So we just find a normal vector. So that will be the determinant of a 3 by 3 vector I. So JK. Then 3, negative 1, negative 1. Then negative 4, negative 12, 0. How do we do this? I'm going to use the top plus minus plus. So I have I. The determinant of what is not under the I. So negative 1, negative 1, negative 12, 0. Then minus J, the determinant of what is not under the J. That's 3, negative 4, negative 1, 0. Then plus K, the determinant of what is not under the K. 3, negative 4, negative 1, negative 12. So that's our normal vector N. So we get I bracket. Negative 1, so this times the diagonals multiply. Negative 1 times 0 is 0. Then minus negative 12 times negative 1, that will be 12, so minus 12. Then minus J bracket. 3 times 0 is 0. Then negative 4 minus negative 4 times negative 1, that will be minus 4. So negative 4 times negative 1 is 4, so minus that. Plus K bracket. 3 times negative 12, that will be negative 36. Then minus negative 4 times negative 1, that will be 4. So minus 4. We have I. Remember that will be the normal vector. I will be equal to 0 minus 12 will be minus 12 minus j negative 4, then plus k bracket negative 36 minus 4, that will be negative 40. So I will polish that very well. Our normal vector n will be equal to negative 12i plus 4j then minus 40k. I hope you get that. I hope you get that. Since we know how to find the normal vector of a plane, we can be able to find the vector equation of the plane. So come with me. So to find a vector equation of a plane that passes through 3 points, you need a normal vector, which we have learned already. So when we know the normal vector n to be ai plus bj plus ck, where I, j, and k are the unit vectors, and a, b, c are constant, and the plane passes through these 3 points, p, q, and r. Then after we find the normal vector given these 3 points, then the equation of the plane will be given as a bracket x minus x1 plus b bracket y minus y1 and plus c bracket z minus z1 all equal to 0. Where a, b, and c are the coefficients of the unit vector, the unit vector of the normal vector. So we'll take some sample questions, then we'll see how we'll put this into practice. So let's solve our first question. It said, find the vector equation of a plane that passes through the point A 1, 2, 2, B 2, negative 1, 1, and C negative 1, 3, 0. So we say that if we have a plane and there is a normal acting on the plane, and let's say the number is giving us AI plus BJ plus CK, where the IJ are scalars, then the vector equation of this plane is A bracket x minus x1 plus B bracket y minus y1 plus C bracket z minus z1 equal to 0, where A, B, and C are the coefficients of the unit vectors of the normal vector. So, how do we find? We need a normal vector. So we need to find a normal vector. We say the normal vector n is equal to the cross product of the directional vectors of the points. So we say AB cross AC. So we find AB first. AB will be equal to OB minus OA. So what's our OB? Our OB is 2, negative 1, 1. So 2, negative 1, 1. Minus OA. OA is 1, 2, 2. So we have 1, 2, 2. When we subtract this, 2 minus 1 will be 1. Negative 1 minus 2 will be negative 3. Then 1 minus 2 will be negative 1. So we can say our AB is equal to 1, negative 3, 1. 1, negative 3, negative 1. So since we find AB, we need to find AC. So our AC will be equal to OC minus OA. So how's our OC? Our OC is negative 1, 3, 0. So we have negative 1, 3, 0. Minus the OA, which is 1, 2, 2. We'll subtract this. Negative 1 minus 1 will be negative 2. 3 minus 2 will be 1. And 0 minus 2 will be negative 2. So we say the normal vector n, remember, is equal to, look at it, the cross product of the directional vector AB and AC. So we say AB cross AC. We find AB to be 1, -3, -1. So let's write our AB is equal to 1, -3, -1. And our AC is equal to -2, 1, -2. Then we can find the cross product there. So our normal vector, which is the cross product, will be equal to IJK. Then we write 1, -3, -1. Then -2, 1, -2. Then we find a determinant of that. So to solve that, we are using plus minus plus. We have I, the normal vector. I will be -3, 1, -1, -2. When we take the I, we will not pick what is under the I. Minus J will not pick what is under the J. So 1, -2, -1, -2. Then plus K will not pick what is under the K. So we have 1, -2, -3, 1, -3, 1. So this will be I bracket. This times this, that will be 6. Minus this times this, that will be so plus 1. Minus J, this times this is -2. Minus this times this is 2, so minus 2. Plus K, this times this is 1. Minus this times this is -2 times -3 is 6, so minus 6. So I have I times 7, 6 plus 1, minus J, -2 minus 2 is -4. Plus K, 1 minus 6 is -5. So I'll polish that. Our normal vector n will be equal to 7i plus 4j minus 5k. Then we can say A is equal to 7, B is equal to 4, and C is equal to -5. So we said to find the equation of a plane, we need a normal vector, and we have found a normal vector. And we said that the equation of a plane then is this. So we say our A is 7, B is 4, compare it, then C will be equal to -5. Then the vector equation of this plane that passes through the 3 point will be 7 bracket x minus x1 is 1, so minus 1. You can use any of the points. Then plus b, which is 4, y minus y1, so that will be 2. Then c is negative, so minus 5. Then z minus is same to equal to 0. So when we expand, we get 7x minus 7 plus 4y minus 8 minus 5z plus 10 equal to 0. So we'll group like this. Get 7x plus 4y minus 5z minus 7 minus 8 plus 10 equal to 0. So we can say the vector equation is 7x plus 4y minus 5z. Then -7 minus 8. Minus 7 minus 8 is -15. -15 plus 10, that will be -5. So minus 5 equal to 0. Then we can say this is the vector equation of the plane that passes through the 3 points. I hope you get that. It's very easy. Please play over the video and you get the concept. Okay, so we'll solve one more question on this. Please, before we do that, remember to subscribe to my YouTube channel and click on the notification bell. Please comment. Your comment keeps me going. Now pause the video and try solving this and see if you can get the answer. So we say that they say find the vector equation of the plane that passes through the points P, Q, and R, and the points are given. And we said that to find a vector in a plane, there is always a normal vector acting on the plane. So the vector equation, if the normal vector n is equal to I plus bj plus ck, where I, j, and k are unit vectors, then the vector equation will be a bracket x minus x1 plus b bracket y minus y1 plus c bracket z minus z1 equal to 0. Where a, b, and c are the coefficients here. I hope you get that. And the normal vector, we said, is the cross product of the directional vector of the 3 points. If you remember that. So we said the normal vector n will be equal to PR cross PQ cross PR. So how do we find PQ? PQ will be equal to OQ minus OP. So what's our OQ? Our OQ is this, negative 1, 1, 2 minus OP. And OP is 102, 102. So we want to polish. Negative 1 minus 1 will be negative 2. 1 minus 0 is still 1. Then 2 minus 2 is 0. And we can say our PQ is equal to negative 2, 1, 0. Then we need to find PR. Our PR will be equal to OR minus OP. What's our OR? Our OR is 503. So I have 503 minus OP, and OP is 102. So 102. We'll subtract this. 5 minus 1 is 4. 0 minus 0 is 0. 3 minus 2 is 1. So since we know our PQ to be negative 210 and our PR to be equal to 401, you can find our normal vector. So we said a normal vector is a cross product of the two directional vectors of the points. So the normal vector n will be equal to PQ cross PR. So this will just be the determinant of the 3 by 3 matrix, so which is negative 210, then 401. So how do we solve this? We have, I'm using the first column, so plus minus plus, so I, the determinant of what is not under the I, 1001, minus J, the determinant of what is not under the J, so negative 2401, plus K, the determinant of what is not under the K, negative 2410. So we calculate that we have I bracket. This time this is 1 minus 1 minus 0 minus 0 is 0. 0 times 0 is 0. So J, negative 2 times 1 will be negative 2. Minus 4 times 0, that will be 0. Plus K, negative 2 times 0 is 0. Then minus 4 times 1, which is 4. So we have I times 1 minus J times negative 2 plus K times negative 4. Now our normal vector n will be equal to I plus 2J minus 4K. I hope you got the normal vector. So with our normal vector, we can find the vector equation of the plane. So with our knowledge, or with us finding the normal vector, then greater part of the work is done. then we can find the vector equation of the plane. We said the vector equation of the plane, if the normal vector is this, then the vector equation of the plane will be this. So we can compare. We know that our A is 1, the B is equal to 2, and C is equal to -4. Where x1 can be any of, you can take any of the points as a point of focus. So I want to use the P. So I can say that my vector equation will be 1 times x minus, my x1 is 1, then plus 2 brackets y times y1, which is 0, then plus c. Okay, so c is -4, so minus 4 bracket z minus z1, which is 2, equal to 0. So when we expand, get x minus 1 plus 2y, this will be 0, so minus 4z, then plus 8, equal to 0. So on group like that, we get x plus 2y minus 4z minus 1 plus 8 equal to 0. You can say our vector equation will be x plus 2y minus 4z, then minus 1 plus 8 will be plus 7 equal to 0. Then these become the vector equation of the plane that passes through the 3 points. I hope you get that. We'll end it here today. Please remember to subscribe to my YouTube channel, like, share, and comment. Until we meet again, bye-bye.